very good afternoon, everyone. This is Shweta Singh, and I warmly welcome you all to Q&A session. This is our second session, right? With class 9. Am I right?
Yes, ma'am.
Okay, so is there anyone who's new to the class who hasn't attended the last session? Oh, okay, fine. So let's have a recap what we did in the last session. So in last session, we got to know what is matter. We said that matter is something which occupies a space and has mass. Then we discussed about the physical nature of matter and about the physical nature of matter. We said we have to write 2 points. What were those points? What were those 2 points? Physical nature of matter? Do you remember? Come on, Hannah, can you tell? Lakshya, please write your name in the correct format. Write Lakshya Matpal, then underscore your school name, underscore your class. And same with Girwin also, please write in the correct format like others have written. Okay, Shubhranshu. Okay, would you like to answer this question? What should you write about the physical nature of matter? You can unmute yourself. You can unmute yourself. Don't waste time in writing. Okay, that's good answer. I forgot. Okay, Hannah, yes, matter is made up of tiny particles. Actually, I told you 2 points to write. The first point was it is particulate in nature. First point you had to write, it is particulate in nature, isn't it? Particulate in nature means it is made up of particles, and particles are very small, so made up of very tiny particles. So these are the 2 points you have to write. Okay, so moving ahead, coming to the assignment now. I gave you 2 questions to match the following. And here is the first question where the physical quantity is given and you have to match it with its SI unit. Yeah. So these are the physical quantities and B is telling you the SI units. So pressure, SI unit of pressure. SI unit of pressure. Pascal,
Pascal.
correct. Exactly. Temperature. These are some general knowledge things which are needed in chemistry also.
मैं
Yes,
Kelvin. मैं Kelvin.
Kelvin. Exactly. Density.
मैं kilogram. No, ma'am. No.
What is density? Mass per unit volume. In a given volume, how much mass is present? Yes, exactly, Shubhranshu. It's not kilometer actually. It's kilogram. Mass per unit volume. So it will be kilogram per cubic meter, right? Kilogram per cubic meter. So cubic meter is the unit of volume and kg is the volume of mass. Okay, mass.
Ma'am, kilogram. Ma'am, kilogram.
Exactly. And volume?
मैं cube meter.
Cubic
मैं
meter.
क्यूब
So do not forget these units. They are some general things that you should know. Okay, moving to the next assignment here. I gave some non-SI units here
yes मैम
and SI units here. So you had to match them. What do you say? Degree Celsius.
मैं केल्विन
Very good. So degree Celsius is actually the unit of temperature. So K should be capital. K should be
yes
capital.
yes मैम
Okay, centimeter.
मीटर में
Exactly. That's the unit of length.
ये
Gram per centimeter
किलोग्राम
cube.
पर मीटर क्यूब.
मैं किलोग्राम पर मीटर क्यूब
And that's the unit of
मैं it's a
unit of
kilogram no
no, that's okay. Like gram per centimeter cube, and its SI unit is kg per meter cube. That's the unit of which physical quantity? Density, right?
yes
Density bar.
मैं पास्कल
And that's the unit of which physical quantity?
मैं forgot
If you'll forget at this speed, how will you remember whole book? Pressure, right? Pressure.
yes
Milligram,
kilogram
kilogram. And that's the unit of which physical quantity?
mass
Mass. Okay. So this is the unit for density, and bar as well as Pascal, that's the unit of pressure. Okay, so some general things that you should know. That's why I gave you this assignment. Okay, now let's move on to the topic of the day. That's properties of particles of matter. So far we did that, what is the physical nature of matter, and we said that matter is made up of very tiny particles. In this session we are going to learn the properties of particles with which matter is made up of. Okay, so let's start now. But before starting, there's a prerequisite that we should beforehand: dissolution. So I explained dissolution in the last session. Do you remember what is dissolution?
मैं dissolutions एक मिनट
Yeah, dissolution.
पे
Anyone? We did in the last session. What is dissolution? That is dissolving solute in a solvent, right? Dissolving solute in a solvent, that's dissolution. Do you know what is kinetic energy? Have you heard about kinetic energy before?
Yes, ma'am.
Yes. So any idea what is kinetic energy? Okay, so basically, kinetic energy is the energy possessed by an object due to its motion. So when something is in motion, when something is moving, right, then the energy which is with the object due to its motion, when it is moving, due to its movement, it has got the energy. That energy is called kinetic energy. Am I clear?
Yes, ma'am. Yes, ma'am.
Okay, fine. So these were the prerequisites, and I'm now coming to the weightage of the topic. Properties of particles of matter. You can get 1 to 3 marks question from this part. It will be definitely based on activity, not directly, but based on activity. But yes, there could be a direct question also, like write the characteristics of properties of matter. But mostly the chances are that the question will be activity based. Okay, let's start now. So what are we going to do? Not conclude, but the characteristic of particles. That's our outline. This is our outline. First, we will see characteristics of particles of matter, and if we get the chance, we will also learn about the diffusion. But we should first finish characteristics of particles of matter. Let's start now. Okay, so first characteristic here. First characteristic, the Particles have spaces between them. That's the first characteristic of the particles of matter, that they have interparticle spaces between them, right? So I'm not saying intermolecular spaces. You must have heard about this word also, that people say that okay, the particles have intermolecular spaces. No, because I said particles can be atoms, particles can be molecules, or they can be ions. So better you call them interparticle space. Okay, so the first property, the particles have interparticle spaces between them. Okay, so how are you going to prove this? For this, we will take 100 ml, like a beaker having 100 ml water, and I'm going to mark its level. Now, I will add 50 gram of sugar into it. Okay, 50 gram of sugar into it. And with the help of glass rod, I'm going to dissolve it. Right, I'm going to dissolve it. So basically, this is nothing but dissolution only. Okay, once I dissolve it, after this again, I will check the level of the water. Right now, once the sugar has been dissolved, now it is no more water, but it's a solution, because it's a mixture now. It's not pure water, but sugar is mixed here, so I'm going to call it a solution. So now again, I'm going to measure the level of the solution, and I'm going to find that level remains same. The level of water remains same. So the question arises, where does the sugar go? So basically, the sugar has taken the space between the particles. So if I represent the water particles with red balls, okay, so sugar particle, I'm going to represent it with blue balls. So it is going to take the interparticle space between the water, and that's why you didn't find the level rising up. Am I clear? Am I clear about the activity here?
Yes, ma'am.
Okay, so what kind of question can be asked here? First, they can give you the activity and then simply ask you, what do you interpret from this activity? So you have to tell that the particles have interparticle spaces, the particles have interparticle spaces between them. Second question can come, where does the sugar go? Why didn't the level rise? You can be asked the reason for it. So again, you have to tell that particles have interparticle spaces between them, and the sugar particles have been accommodated in the interparticle spaces. Okay, so this is how you need to write the answer. Okay, so this activity indicates that particles of matter have spaces between them. See, Himanshu, once, you know what, you keep on adding sugar, you keep on adding sugar, it will get dissolved, it will keep on dissolving, right? Once a time will come when it will stop dissolving. It means all the spaces have been occupied by the sugar particles. So now it's no more getting dissolved. So now we say, okay, now it's saturated solution. You can't dissolve any more sugar. Understood, Himanshu? So till the spaces will be there, the sugar will keep on dissolving and the level won't rise. Okay, fine. Let's move on to the next one. Next property here. Next property of the particles. They have interparticle forces of attraction. The particles of matter attract each other. Now, how are you going to prove it? That okay, they have the interparticle forces of attraction between them. So here are three objects: chalk, iron nail, and ice cube. So if you hit them with hammer, what do you think? Which is, going to resist any change, or going to resist to break up?
Iron nail.
Exactly, iron nail, right? Iron nail. Chalk will break, instantly, and same with the ice cube, but iron nail won't break. Why? Because the particles, the iron atoms which are present in the iron nail, they have strong forces of attraction between them. So the forces of attractions are strongest in case of iron nail. That's why the particle, like, it is not getting broken up by hammer. Fine. So this is an activity which is going to show that particles of matter attract each other. uh, the forces of attraction can be weak or can be strong. Okay, now coming to the third property, that's the kinetic energy of particles. Means the particles are continuously moving, and that's why I'm saying the particles have kinetic energy. Why? Because they are continuously moving. That's the third property. The first property, they have interparticle spaces between them. Second property, the particles of matter have interparticle forces of attraction between them. And third property, they are continuously moving, or I can say they have kinetic energy. Now, how can I prove this? For this, I can simply take water in a beaker, and then I'll put few crystals of potassium permanganate. I'm not going to stir it. Okay, I put potassium permanganate crystal into it, and I'm not going to stir it. I will leave it like this only. And I will observe that after some time, the dark purple color is going to spread in whole of the water. Right? It's going to spread in whole of the water by its own. Why is it happening? Because the particles are moving, right? The particles are moving. The particles of water are moving. Particles of potassium permanganate are moving. So when they move, they get intermixed with each other, and that's how the whole of the water gets dark purple color. Fine. So this intermixing of particle, okay, this intermixing of particles is called diffusion. Right? So when you have to define what is diffusion, the key words are the intermixing of particles on their own. Right? So the key words for the definition of diffusion, that's intermixing of particles on their own. That's very important. On their own, that is called diffusion. Yes, you can take, Girwin, no issue. You can take. Okay, you can take ink also in place of potassium permanganate, so whole of the water color will change, right? So this intermixing of particles is called diffusion. Very important definition of diffusion. And in definition itself, on their own, don't forget to write this. Okay, so this activity actually shows that the particles are continuously moving. Any doubt here so far? Yes, Shubhranshu, Laksh, Hannah, Girvin, any doubt or all clear?
No,
Okay,
ma'am.
so let's repeat once again. What was the first property we did? First property? Come on, everyone. Yes, so particles have interparticle spaces between them, they have interparticle forces of attraction between them, and they are continuously moving. And for each of the property, we saw different activities. Okay, now coming to this activity. Now look at this activity. Here we are going to talk about viscosity. What's the effect of viscosity on diffusion? Okay, so we will see what's the effect of viscosity on diffusion. Okay, so just give me a second. Let me see. Can I run it? Yeah, look at this. So one side I'm having honey, and in the second beaker I'm having ink. Just give me a second. Yeah. So you can see here, this is honey and this one ink, and we are putting it into the water. So what do you observe here? What's the observation? Can you tell? What's the observation here? See again. Exactly, Girwin. Ink is diffusing faster than honey. So, what is the difference between honey and the ink? The honey is more viscous. When I say viscous, it means its flow is restricted. It doesn't flow very fastly, right? And why is it happening? Why is it so viscous? Why its rate of movement is so slow? Because the forces of attraction between the particles are stronger, right? Within the honey, the forces of attraction between the particles are stronger as compared to ink, so it is not allowing it to flow, right? It is not allowing it to flow. So I said that it is viscous. Honey is viscous, so rate of diffusion is slower. It means it's the rate with which it is actually getting diffused, or it is getting intermixed, that is slower in case of honey. Am I clear about this activity? This is given in NCRT. Okay, so you should know.
Yes, ma'am.
Okay, so here let's write down one point here. Rate of diffusion decreases with increase in viscosity, right? With increase in viscosity. I hope you people are noting down all the key points. Yes, guys, are you writing everything? Good. Good. So do write this. The rate of diffusion decreases with increase in viscosity, and we saw it with the activity of honey and ink. Now we are going to go to different factor which is going to affect the rate of diffusion, and that's temperature. That's temperature. Okay. So when let's look at this activity now. Just give me a second. Yeah. So here I'm having hot water, and in this one cold water. And I'm going to put potassium permanganate in both of them. Potassium permanganate in both of them. What do you observe? Yes, what do you observe? You can unmute yourself. It's not like 50 students are sitting here, so everyone will be speaking. You people can unmute yourself. Yes, what do you observe from this activity? Potassium permanganate diffuses faster in hot water. Exactly. Wait, Kevin, the dilution is something else. I explained dilution in the last session. Dilution is addition of water, right? Adding water to a solution is called dilution. So I'm not going to I'm not saying that this activity is related to dilution, but we are going to check the rate of diffusion in hot water and cold water. And we got to see here, we got to observe here that the rate of diffusion is faster in hot water. Why is it so? This is because the kinetic energy of particles increases with the increase in temperature. Right? So when you increase temperature, kinetic energy of particles increases, and that's why the particles are getting intermixed at faster rate, because of which we see that rate of diffusion is faster in higher temperature. So I can simply say rate of diffusion rate of diffusion increases with increase in temperature. And if somebody asks you why is it so, you are going to say that with rise in temperature, kinetic energy of particles increases, right? So I hope you understood this whole concept. Why is it increases with increase in temperature? Because kinetic energy of particles increases with rise in temperature. So now the particles will be moving at much faster rate at higher temperature, and so the rate of diffusion increases. I hope you got the points here. Okay, so let's move ahead now. So coming to the diffusion, we actually saw everything about the diffusion, but formally, like, let's introduce what is diffusion. It's intermixing of particles on their own. It's intermixing of different types of particles on their own. That is diffusion. So, what could be different examples of diffusion? When your food is being cooked, in the kitchen, you get the smell even in your living room, even in your study room. So, this is how, because the food particles are traveling, because particles are continuously moving. So, food particles are getting intermixed with the particles of the air, they are continuously moving and reaching up to you. Okay, this is one of the example of diffusion. Next one, how do aquatic animals get oxygen in water? Because oxygen is in atmosphere. How do they get oxygen in water? Why? Because oxygen gas diffuses into the water and then gets dissolved into it, right? So how do they get oxygen? How do they get oxygen? The oxygen in the atmosphere that gets diffused in water gets dissolved in it, and then aquatic animals take up the oxygen, which is dissolved oxygen, which is present in the water. Okay, that's the second example of diffusion. Coming to the third one, spreading of ink. Spreading of ink into the water, that's another example of diffusion. Okay. Okay, next example. The smell of perfume spreads due to the diffusion of vapor into air. So, how are we able to smell the perfume? Because its particles, right? Its particles are getting diffused in the air. So, this is how we get the smell of the perfume. Now you may think that okay, this is the easy one, like what kind of thing we are doing, but believe me, this kind of question actually comes in exam. They can simply ask you how are you able to smell the perfume, so you have to write this only. The smell of perfume spreads due to the diffusion of perfume vapor into air. Okay. Diffusion can be seen everywhere, even in the solid also, but it is very, very slow. So if I say, where can we see the diffusion in solid? We write on the board with the help of the chalk. What is happening? The chalk is actually getting diffused into the board. So that's one example of diffusion when we write on the board with the help of chalk. Okay, so you got to see different examples of diffusion here. One thing I would like to tell you about diffusion, this is out of syllabus, right? It is out of syllabus, but you should know something extra, that rate of diffusion, right? Rate of diffusion is inversely proportional to the density of the substance. Or if I say gas, right? In terms of gas, I can say density inversely proportional to the density of the gas. Okay? So do remember this. Even we can say it rate of diffusion is inversely proportional. I hope you understand the meaning of inversely proportional. Okay, so inversely proportional to the mass of the gas also, right? Mass of the gas also. That's the Graham's law of diffusion. This is something we study in higher classes, but I think this much you can remember, right? Rate of diffusion is inversely proportional to the density of the gas. Or I can say rate of diffusion is inversely proportional to the under root of mass of the gas, right? Now, you may get, see, in NCRT, you are not going to get the numerical on it, but it is possible in Olympiad, you can get the, numerical based on it. But simply the fact based question can be asked, like two gases are given A and B, one is having this much density, other is having that much density. So for which of the gas the rate of diffusion will be faster? So if you know this relation between them, you'll be able to solve it. So that's called Graham's law of diffusion. Okay, so what was the question, Samagna? How's that slow process? Diffusion, because the solid particles, in solid, the particles are very close to each other. So they have strong intermolecular forces of attraction, interparticle forces of attraction between them. So that won't allow it to move faster. Okay? When we will compare no the three states of matter, then you will get to know, okay, the about the properties of the particles there, which has got higher kinetic energy, which has got slower kinetic energy. Understood, Samagna? And Gerwin, you didn't understand. So when you write with the chalk, when you have a green or black board and you use the chalk to write into it, how do you see that it is being written on the board? Because the chalk particles are getting diffused into the space which is present in the, in the board. Understood? Okay, so let's move ahead now. So now we are done with the different characteristics of particles of matter. Means we did the properties of particles of matter. So what were they? First thing we did, that particles of matter are very small. So I can introduce into it. It's okay. It's telling the physical nature of matter also. And definitely it is one of the characteristics of particles of matter that they are very small in size. Okay. Second, the particles of matter have spaces between them. Means they have interparticle spaces between them. Third point, the particles of matter are constantly moving, and with rise in temperature, their kinetic energy increases. Next one, the particles of matter have interparticle forces of attraction. So you got 4 points here, right? You got 4 points here. Particles of matter are very small, they have space between them, constantly moving, and with rise in temperature, they are moving faster, and particles of matter attract each other. Now, can you see a Google form is being shared here? Can you see the Google form being shared
Yes,
in your
ma'am.
chat box? So after the class, before leaving, you need to fill up this form. That's very important. Okay. Fine. So can anybody tell me which activity we did to tell that particles of matter are very, very small? Can you tell? Which activity we did to tell that particles of matter are very tiny? You can speak. Come on, you can unmute yourself. Yes. Laksh, would you like to answer? When we dissolved potassium permanganate, we took 100 ml water in a beaker and we added 2-3 crystals of the potassium permanganate, and it got colored, like whole of the water got colored dark purple. And then we started taking up 10 ml and added into 90 ml water, and this is how we kept on transferring them, and the color was getting faded in every beaker. That was the activity. Which activity did we do to prove that the particles have interparticle spaces between them?
Adding sugar into water.
Exactly. The level of the water didn't rise. The particles of matter are constantly moving.
Adding ink in water.
Yeah, ink or potassium permanganate, when you just keep it into the water, it will get dissolved by itself. Okay, and what did we do to prove that with rise in temperature, the particles are moving faster?
Adding potassium permanganate into hot water and
As
cold
well as
water.
cold water. Yeah, simultaneously we took both of them. Very good. And the particles of matter attract each other. Yes. Which activity we did? The particles of matter attract each other. We took chalk, iron nail, and ice cube, and we saw that it's not easy to break iron nail. Okay, so this is these are the things that you should remember from this particular class. Now moving to the next one, what do we need to do in the next session? We will be studying different states of matter. We will see solid, liquid, gas, and other two states also, based on the properties of particles of matter. Okay, and before I leave the class, like once you get your login ID, okay, once you get your login ID, just give me a second. After that, you have to attempt questions. From where will you attempt your questions? You will go to the platform like this. Now this is the class 9th platform. You'll go to assessment. Then in the custom, you look for the science segment. In science, go for the chapter is matter in our surrounding. Then view topics, where you will find different topics of matter in our surrounding, like understand matter, we did. Demonstrate that matter is made up of tiny particles, yes, we did. Then demonstrate the particles have spaces between them. This is something we did today. You can simply select it and start attempting the questions on it. Okay, so like if I select this, right, if I select it and start practicing, like, can you solve this question? A teacher demonstrated that after adding copper sulfate to water and stirring, the liquid appeared uniformly blue with no particles at the bottom. What scientific classification best fits the mixture? Compound, heterogeneous mixture, element, or solution? What should be the answer? Copper sulfate. Okay, D. So Hannah is telling me D. Let me mark D. Let's move on to the. So she's saying that if I add copper sulfate into water, I stir it and it gets uniformly mixed, it is forming solution. Okay. Moving to the next question here. Arav conducted an experiment where he added salt to a fixed amount of water in a measuring cylinder. Despite adding multiple spoons of salt, the water level didn't rise significantly. What explains this observation using the particle nature of matter? Water evaporates quickly when stirred, salt
D.
particles float. Okay, so you are saying D, that salt particles occupy intermolecular spaces in water because the level didn't rise. So let me mark D here. Let's solve one more question now. A group of students observed that even after dissolving 5 spoons of sugar in 200 ml of water, the water level barely changed. Their teacher encouraged them to think that at the particle level. What explanation best fits this observation? Sugar particles float, water evaporates quickly, sugar
Um,
molecules, sorry,
Option C.
you mean sugar molecules fit into intermolecular spaces of water. Let's mark it
Yes,
C
ma'am.
and I will submit the test. Let me submit the test. Okay, so your all three questions are correct. But if you go wrong, how will you check? You can simply go to review question. Okay, you can simply go to the review question. Fine. Now, here you will see, suppose I have made this wrong or I would like to know the correct answer. So I can simply make it full screen and I will get, see how is it explained here. What is given in the solution? A question, copper sulfate dissolves completely and evenly in water. What is asked in the question? What type of mixture is this? How will you strategize your answer? Compare visual properties and particle behavior with mixture type. So it is not giving you answer directly. It is telling you to think on it. Now coming to the solution. A mixture is a solution because copper sulfate dissolves completely, forming mixture with no residue or visible particles. So to solve this question, you should read about solution, the definition of solution. Okay, so in this way, you will only focus on those things which you don't know, right? So it, actually saves time. Okay, now you have attempted the questions. You have to see your score. You have seen your score. Now coming to the dashboard. The more you practice, your MyQ score will keep on increasing if you, the way you practice based on it. Okay, and here the topics of your strength, opportunity, hurdles, weaknesses are given, including physics. Including maths, science, and social science. So, like, I'll just show you 18 topics are the strength, right? So, these are the 18th topic, which includes all the topics of math, science, and social science. So, if you want to practice on the opportunities, right? If you want to practice on the opportunities, because opportunity is something where you practice little bit and you'll be master of that topic. So, you can simply go to the opportunity and you can pick up any of the topic on which you want to practice. Okay, so this is how you have to practice. Now coming to the analytics part, so it is going to show you how are you performing day by day, and it is going to show with respect to your classmates, how are you performing. This graph actually shows your performance and your class average performance. Okay, so very useful thing, very useful thing. And based on the more you practice on this platform, accordingly we get the picture from this platform that okay, Hannah doesn't know this topic very well, or Himanshu needs to practice on this topic. Accordingly we will arrange need based tutorials on these Saturdays. Okay, fine. So this was about the platform. Don't forget, in the next class, we are going to study about different states of matter. So that's it for this session. Thank you, everyone. Do you have any doubt? Any doubt, anyone? And don't forget to fill that Google form. Okay. So thank you. We'll see Samag now. Let's first, go through few classes and then we will decide. Okay. Thank you, everyone. Take care.